Hello student, how are you? I am Arun sir. Welcome to my channel Tuition Expert. Today in this class, I will teach you the expansion of solid and liquid with derivation. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the IITJee exam and NEET confidently with a good rank. Now let's start about the class. So today's topic is expansion of solid and liquid. First we discuss about the expansion of solid. We know, suppose this is a rod of initial length L. Now if heat is supplied, then the rod length of the rod will be increased. Length of the rod will be increased, and this length is suppose L2. When heat is supplied to the rod, the length of the rod will increase. The temperature, initial temperature is T1 degree centigrade and final temperature is T2 degree centigrade. Now what is the theory of expansion here? Expansion, that is increase of length equal to L2 minus L1. This increase of length is proportional to the initial length. That is, as more length, expansion will be more. So increase of length del L is proportional to initial length, and also increase of length is proportional to temperature rise, that is T2 minus T1, which is equal to del T. This is the theory, that is increase of length is proportional to initial length, that more initial length, more length, and expansion is also more, and also increase of length is proportional to temperature rise. More temperature rise means more expansion. So this is the theory, and this is proportional to L1 into del T, which is proportional to L1 into alpha. This is not proportional, this is alpha into del T, L1 alpha into del T. Del L, when we use equal to sign, a constant term is at here. This constant term is called coefficient of linear expansion alpha, L1 into del T. Now del L equal to L2 minus L1, so L2 equal to L1 plus L1 alpha into del T, L1 1 plus alpha into del T. So L2 equal to this. So this is the formula, L2 equal to L1 into 1 plus alpha del T. Now what is the alpha? Alpha is coefficient of, this is the formula, and alpha equal to coefficient of linear expansion, coefficient of linear expansion. Now what is the formula of alpha? Alpha equal to L2 minus L1 by L1 into del T. So L2 minus L1 is unit, is its unit is centimeter, centimeter by centimeter cancel, and del T is unit of del T is degree centigrade, so unit is per degree centigrade. This is the unit, per degree centigrade. So alpha is defined as the fractional increase of length. This is called fractional. This is called fractional increase. This term is called fractional increase of length. Fractional increase of length per unit degree centigrade, unit degree centigrade rise, That is, if the temperature rise is unity, then the fractional increase of the length of the body is called the coefficient of linear expansion. L2 minus L1 is increase of length by original length, increase of length by original length by temperature rise. This term is called coefficient of linear expansion. So the formula is This is the formula. L2 equal to L2 is final length, L2 equal to final length, L1 is initial length, and del T is temperature rise. Del T is temperature rise. Next term is superficial expansion or aerial expansion. This term is denoted by beta. Now similarly, similar to the coefficient of linear expansion, suppose this is a plate, rectangular plate of surface area S1, surface area S1 at temperature T1 degree centigrade. If heat is supplied, then the surface area increases. If the surface area be S2 at T2 degree centigrade, then we can say that the increase of surface area S2 minus S1, which is del S, this is proportional to initial surface area S1, and also del S is proportional to temperature rise del T. Always we use del T temperature rise equal to T2 minus T1. So del S is proportional to del T and del S is proportional to S1. If we combine, then S1 into del T, that is del S equal to beta S1 del T. Now del S equal to S2 minus S1 equal to S1 beta into del T. So S2 equal to S1 into 1 plus beta into del T. So this is the formula. So this is the formula of S2. S2 equal to final surface area. S2 equal to final surface area. S1 equal to initial surface area. Okay. S1 equal to initial surface area and del T equal to temperature rise. Temperature rise. Coefficient of superficial expansion, which is denoted by S2 minus, which is the formula, which has the formula S2 minus S1 by S1 into del T. So this is the formula of beta. Now it is also defined as the fractional increase of surface area per unit degree centigrade rise. So its unit will be per degree centigrade, because this and this has same unit, so unit is per degree centigrade. Volume expansion, cubical or volume expansion. Now if a body has the volume V1 at T1 degree centigrade, and if we applied heat, here the volume will be increased. So the final volume is suppose V2 at T2 degree centigrade. Now what is the expansion of volume V2 minus V1? This also similar way is proportional to initial volume and also proportional to temperature rise. So if we combine V2 minus V1, this is proportional to V1 into del T, which is equal to gamma into V1 into del T. So V2 equal to V2 equal to, formula is V2 equal to V1 into 1 plus gamma del T. This is the formula. And increase of the volume also formula is gamma V1 into del T. This is also one formula. V2 equal to final volume, initial volume, gamma. What is gamma? What is gamma? Gamma equal to coefficient of volume expansion. Coefficient of volume expansion, that is v2 minus v1 by v1 into del T. This is also fractional increase of volume per unit degree centigrade rise. So its unit also per degree centigrade, alpha, beta and gamma. Derivation. So first we take a surface area S1 at T1 degree centigrade. Now if heat is supplied, then the surface area will be increased. Suppose these are the surface area S2 at T2 degree centigrade. Now if the initial length of this plate is A, length is A and breadth is B. So take the surface area S1 of dimension A cross B, that is A is initial length and B is final length. Now this length will be increased at T2 degree centigrade. So this is suppose A1, this length is increased to A1 and breadth is increased to B1. Now what is S2? S2 equal to A1 into B1. S2 equal to A1 into B1. Now what is A1? A1 equal to A into 1 plus alpha into del T, where del T equal to temperature rise T2 minus T1. This length is increases to A1 and breadth is increased to B1. So surface area S2 equal to A1 B1. Now A1 equal to what? A1 equal to this length. This is the final length, this is the initial length. So A1 equal to A into 1 plus alpha T and B1 equal to B into 1 plus alpha into del T. Now A into B equal to S1 and whole square. So S1 into 1 plus 2 alpha into del T plus alpha square del T square. As we know, the value of alpha is always minus 5 or minus 6 order, minus this order. So value of alpha is very negligible. So its square term is negligible. So S2 equal to, we get S1 into 1 plus 2 alpha del T. S2 equal to this. So this is the one relation, S2 equal to S1 into 1 plus 2 alpha del T. Now if you define the beta, coefficient of superficial expansion, equal to coefficient of superficial or radial expansion, then by definition beta equal to S2 minus S1 by S1 into del T. From this we get S2 equal to S1 into 1 plus beta into del T. So from this and this, suppose this is 1 and this is 2. So from 1 and 2 we get beta equal to 2 alpha, that is alpha equal to beta by 2. This is the relation alpha and beta, alpha equal to beta by 2. Next, cuboid of volume whose dimension is ABC, that is length is A, breadth is B and height is C. Now this is the cuboid at temperature T1 degree centigrade, and if we apply the heat, some heat, that is if the cuboid is heated, the final volume becomes this length will be A1, this length will be B1 and this length will be C1. So final volume is V2 at T2 degree centigrade. Now what is the V2? V1 will be A into B into C and V2 will be A1, B1, C1. Now A1 equal to A into 1 plus alpha del T, B1 equal to B into 1 plus alpha del T and C1 equal to C 1 plus alpha del T. So this equal to ABC 1 plus alpha del T whole cube, that is V1 into, if we expand this, 1 plus nx or a plus b whole cube equal to AQ plus BQ plus 3A square B plus 3AB square. So AQ plus 3A square B, 3A square B, and next term is 3AB square, 3 square alpha square del T square plus BQ alpha Q del T whole cube. Now as alpha is very small, this term is negligible, this term and this term is negligible, so we get of gamma. What is gamma? Gamma equal to V2 minus V1 by V1 into del T. From this we get V2 equal to V1 into 1 plus gamma del T. So this is suppose 3 and this is 4. So from 3 and 4, from 3 and 4 we get 3 alpha equal to gamma. So alpha equal to gamma by 3, and also we get from previous relation alpha equal to beta by 2. So this is the relation, alpha equal to beta equal to 2 alpha and gamma equal to 3 alpha. So this is the relation. Variation of density with temperature of a solid body. Variation of density with temperature of a solid body. How density varies with temperature. Suppose this is a body of mass m and its volume V1, density D1 at T1 degree centigrade. Now if we heat it, if some heat is supplied to the body or the body is heated, then the volume will be V2, density D2 at T2 degree centigrade, but mass of the substance remain same. Mass remains same. So T2 greater than T1. Now we find the relation between D2 and D1. D2 and D1. Suppose gamma is the coefficient of cubical expansion of the body. Now we know mass equal to volume into density. Here mass equal to volume into density. Now D2 equal to V1 by V2 into D1, which is V1, V2 equal to V1 into 1 plus gamma del T into D1. V1 cancel. So the relation is D2 equal to D1 into 1 plus gamma del T whole to the power minus 1. That is, this is the relation. So D2 equal to this is the relation. To solve the problem we use this formula. This formula. This or this, sometimes this is written as this or this. So this is more accurate than this. Here some assumption is made. Now this is more accurate than this. So we use this formula to solve this problem. Topic is how time period of pendulum increases with temperature. How time period of a pendulum, simple pendulum varies with temperature. We know time period of a pendulum is, T equal to twice by root over L by G. This is the formula of time period of a pendulum. As length of the pendulum increases with temperature, then time period will increase. The time period increases means time period increases means it's the clock will slow. The clock will slow because time period is more means it will be slow. Now what is the effect of time period with temperature? To find this, suppose we get time period is T1 at when temperature is T1 degree centigrade. Now the length is L1 at T1 degree centigrade. Now the time period T2, when length is L2, this length is at T2 degree centigrade. T2 degree centigrade. This length is at T2 degree centigrade, because length, if the temperature rise, then length increases. So length L2 is at T2 degree centigrade and length L1 is at T1 degree centigrade. Now to find, now we divide this by this, T2 by T1. What happens? This is L2 by L1. Now L2 equal to L1 into 1 plus alpha into del T. Del T means temperature rise, which is equal to T2 minus T1. T2 minus T1. So this becomes 1 plus alpha del T whole to the power half, which is equal to 1 plus half alpha into del T. So this is the relation now. T2 by T1 minus 1 equal to half alpha into del T. So T2 minus T1 by T1 equal to half alpha into del T. So T2 minus T1, this is called fractional increase of time period, or T2 minus T1 is del T. So del T equal to half alpha del T into T1. So this is the relation. So from this relation we get the increase of time period or percentage increase of time period, etc. we get from this relation. What is del T? Del T is temperature rise. Del T is temperature rise. Okay. And next topic is expansion of liquid. Expansion of liquid. Now to study the expansion of liquid, the liquid must be kept in a container. In solid, if the solid is heated, we don't need any container to study the expansion of solid, but to study the expansion of liquid, we need a container. This is a Bunsen burner. Suppose this flask, some liquid is kept in this container, in this flask, and this flask is heated by Bunsen burner, and here a tube is inserted through this cork such that some liquid is rise through this tube. Now when the flask is heated, then the liquid expands. First the volume of the metal of the container increases, then after some time the liquid of the container increases. So when the volume expands of the when the volume of the liquid expands, then it rises through this tube. It rises through the tube. Now what happens at the first, that suppose initially the liquid is at here up to the level P. Now at the initial stage, the liquid does not rise. What happens? The liquid first falls to the R. First liquid falls up to level R, and then it rises up to Q. So what? First the liquid level is at P. When temperature, when it is heated, then at the initial stage the liquid levels falls to the point R, and if the heating process is continuous, heating process continues, then the liquid level rises and it reaches up to Q point. So why the liquid level falls? Because initial state the volume of the container increases as the expansion of fast the volume of the container, that is fast the container, the metal of the container gets heat, so its volume increases. So the volume increases, that means the liquid level falls at first, but after some time when the liquid takes the heat, then its volume increases. As the volume expansion of the liquid is more than the volume expansion of solid, then the liquid level rises more and it reaches up to point Q. So here, if A is the cross section area of tube, we say that now PR, what is PR? PR equal to the PR, now PR into A, this is the volume expansion of solid, that is volume expansion of container, suppose this is glass container, suppose this is glass. Now what is the R2Q RQ into A denotes the real expansion of liquid. Now what is PQ into A? This denotes actually apparent expansion, because at the first liquid level is at P, then after some time it rises to Q. So this actually this is the apparent expansion of liquid. Apparent expansion of liquid is PQ into A. Length into area equal to volume. So length into area equal to volume. So this is apparent expansion of liquid. Suppose somebody watch the initial level at P and he is not present while it is heating process is going on, and after some when he reaches at here and watch that the liquid level rises up to the point Q. So Q is the rise of the level of the water, so that's why PQ into A is the apparent expansion of liquid. But actually liquid level falls up to R and liquid level rises from R to Q. So QR is the actual, QR into A is the actual real expansion of liquid. But man watch that initial level is P and final level is Q. So PQ is the PQ into A equal to apparent expansion of liquid into A equal to QR equal to PR plus PQ into A. So QR into A. So now if the initial volume of the container and liquid, if the initial volume is V0, so divide by V0 into del T, temperature rise, divide both sides by V0 into del T. Now QR into A is equal to volume expansion of real volume expansion. V0 is original volume, initial volume. So this is the gamma of QR is real expansion of liquid. Coefficient of real expansion of the liquid is denoted by this term, and PR by this, PR into A by this. The PR, what is PR? PR equal to volume expansion of container or glass. So this is gamma G plus PQ. What is PQ? PQ into A apparent expansion of the liquid. So this is gamma A. So this relation is holds for the liquid. Gamma real expansion of liquid equal to real expansion of gamma plus apparent expansion of the liquid. Real expansion of the container plus apparent expansion of the liquid. So this relation holds for the liquid. So when we take the real expansion of the liquid, we take the expansion of the coefficient of expansion of glass plus apparent expansion of the liquid. Anomalous expansion of water. So we know when suppose a container, some ice is present at a container, this ice, the temperature is -5°C. Okay, now when it is heated, heat supplied, then what happens? This converted to water, Suppose this is 0 degree centigrade water, and when heat is supplied, then it is converted to the temperature of the liquid water is rises. Temperature of the water is rises. Zero to 4. When 0 to 4, volume decreases. Suppose this volume up to this, and this volume decreases. 4 degree centigrade up to this. So this is V1, this is V2. And when heat is supplied at here, V3, again it rises. In a container, ice temperature minus 5 degree centigrade. When heat is supplied, then temperature rises. Suppose it reaches to 0 degree centigrade. Now when heat is supplied at here, the temperature rises from 0 to 4 degree. Now the volume of the water decreases, that is volume of the water decreases, that is V2 now less than V1. Again, when temperature rises from 4 to 50 degree centigrade, then the volume V3, suppose this is the V3 volume, V3 greater than V2 greater than V1. So at 4 degree centigrade, volume of the water is minimum. Volume of the water is minimum means density is maximum. So at 4 degree centigrade, volume of water is minimum. Minimum means density at 4 degree centigrade is maximum. But for general liquid, for any other liquid, as the temperature rises, volume becomes gradually increases. So for water it is happens, that is temperature rises. When temperature rises for water from 0 to 4 degree centigrade, volume decreases. But for other liquid, when temperature rises, then its volume increases for other type of liquid. So this is the anomalous expansion of water. After 4 degree centigrade, 4 to 5 degree centigrade, like as another liquid, the volume increases. But 0 to 4 degree centigrade, this expansion is anomalous with the other liquid. This is called anomalous expansion of the water. So if we draw at 4 degree centigrade, volume is minimum, and density versus temperature. So 4 degree centigrade, density is maximum, volume is minimum, and density is maximum. How apparent weight of a body changes with temperature rise. How apparent weight of a body changes, within liquid changes with temperature rise. Suppose this is a container, some liquid is present at here, and a body is immersed, suspended, and it is immersed, and the body is suspended within this liquid. The weight of the body, suppose the weight of the mass is m, weight of the body W1 equal to mg minus buoyancy force. Now this is buoyancy force, and weight act in this way, buoyancy force act. So density of the liquid is d1 at T1 degree centigrade. Now if the temperature of the liquid rises, if the liquid is heated, then what happens? If the liquid is heated, then what happens? If the liquid is heated, what happens? Mass remains same, weight remains same, mass m into g remains same, but here buoyancy will be changes. V2 as density change and volume of the body also change, then buoyancy changes, because formula of buoyancy force equal to volume displaced VdG into density of liquid into G. Buoyancy force is volume displaced volume of the displaced liquid into density of liquid into G. So this is at T degree centigrade. Now here apparent weight W2 equal to mg minus, this is B1, this is B2. So W1 and W2 which is more? W1 and W2 which is more? Now question is W1 equal to W2 MCQ question. W1 equal to W2 or W1 less than W2 or W1 greater than W2 or W1 equal to 2W2. So these are the question. So if temperature T2 greater than T1, if temperature rises, that is liquid is heated, then what happens the apparent weight of the body? Now here W1 equal to this and W2 equal to this. Now we have to relate what is W2 and W1. Now W2 equal to W2 equal to buoyancy force mg minus so now W1 minus W2 equal to what? W1 minus W2 equal to B2 minus B1. This minus this is B2 minus B1. Now what is B2? B2 equal to V2 density of the liquid into G minus B1 equal to V1 D1 G. Now V2 equal to what? V1 into volume of the body V1 into 1 plus gamma solid into temperature rise del T, and D2 equal to what? D2 equal to D1 by 1 plus gamma liquid into del T minus V1 D1 G. So take common V1 into G, V1 D1 G, take common, we get 1 plus gamma S del T divided by 1 plus gamma L del T minus 1. Now what is gamma S? Gamma is equal to coefficient of volume expansion of solid, and gamma L equal to coefficient of volume expansion of liquid. We know gamma L greater than gamma S always. So if we calculate this, what happens? So W1 minus W2 equal to if we multiply 1 minus gamma L del T plus gamma S del T minus gamma S gamma L del T square minus 1. So 1 and 1 cancel, and this also cancelled, and this value V1 D1 G del T common, gamma S minus gamma L, as this gamma L greater than gamma S, gamma L greater than gamma S, so this is less than 0, that is W1 less than W2. So W1, so we get W1 minus W2 less than 0, that is W2 greater than W1. That is, if temperature rises, then the apparent weight increases. If temperature, the conclusion is that if temperature rises, apparent weight increases. Apparent weight of a body increases. Student, this is the end of the class today. To get more important problem in expansion of solid and liquid, watch my another video. Okay, thank you.